Physical contaminants in food may include A. Glass fragments, metal shavings, or fish bones and fillets. B. Bacteria. C. Viruses. D. Fungi. Answer A. Physical contaminants are unwanted objects such as glass, metal, or natural parts, like bones, that can accidentally enter food. Deliberate food adulteration may be perpetrated by A. Only external terrorists. B. Disgruntled employees or competitors. C. Innocuous suppliers. D. Regulatory authorities. Answer B. Malicious individuals, including unhappy current or former staff or competitors, may intentionally tamper with food. A food defense program is designed to A. Facilitate improper food handling. B. Protect against intentional contamination. C. Lower hygiene standards. D. Ignore food safety concerns. Answer B. A food defense program is implemented to safeguard the food supply from intentional acts of contamination. The ALERT acronym in food defense stands for A. Assure, look, employees, reports, threat. B. Alert, listen, examine, react, test. C. Avoid, limit, exclude, remove, terminate. D. Assess, lessen, ensure, review, track. Answer A. ALERT outlines key steps: assure, look, employees, reports, threat, to monitor and respond to potential food defense issues. Response to a suspected foodborne illness outbreak involves A. Ignoring customer complaints. B. Gathering information, segregating suspect products, and documenting incidents. C. Continuing operations without intervention. D. Discarding all food items immediately. Answer B. Proper response includes collecting detailed information, isolating questionable products, and collaborating with regulatory authorities. Managing food allergens in a facility is critical due to the risk of A. Minimal allergic reactions. B. Severe allergic reactions, including anaphylaxis. C. Harmless allergen exposure. D. Allergen elimination through cooking. Answer B. Food allergens can trigger severe, potentially life-threatening reactions, making allergen management essential. The big 8 food allergens include A. Milk, eggs, fish, peanuts, soy, wheat, crustaceans, and tree nuts. B. Only gluten. C. Only dairy products. D. Only seafood. Answer A. These 8 allergens are responsible for the majority of food allergy reactions in the United States. Mandatory labeling of allergens on food products is enforced by A. Federal law. B. Informal restaurant guidelines. C. Unwritten rules. D. Local recommendations without legal backing. Answer A. Federal regulations require that manufactured foods clearly identify the presence of major allergens on their labels. Prevention of allergen cross-contact is achieved by A. Using the same utensils for all foods. B. Mixing ingredients without precaution. C. Ignoring cleaning protocols. D. Rigorous cleaning and sanitizing of equipment and hands between tasks. Answer D. Proper cleaning and segregation of equipment prevents the unintended transfer of allergens between foods. A robust personal hygiene program for food handlers emphasizes A. Wearing unclean uniforms. B. Hand washing, personal cleanliness, and ongoing training. C. Minimal training. D. Occasional supervision. Answer B. Effective hygiene programs require strict hand washing, proper personal care, and regular training to minimize contamination risks. Sinks designated solely for hand washing must be used exclusively for A. Hand washing. B. Food preparation. C. Dishwashing. D. Waste disposal. Answer A. To avoid cross-contamination, hand-washing sinks should only be used for washing hands, not for food prep or dishwashing. Use of single-use gloves when handling ready-to-eat food is intended to A. Allow glove reuse. B. Prevent contamination of ready-to-eat foods. C. Replace hand-washing entirely. D. Promote cross-contamination. Answer B. Single-use gloves act as a barrier to protect ready-to-eat foods from pathogens, provided they are used properly along with hand-washing. Calibrating thermometers is essential to A. Provide inaccurate temperature readings. B. Prolong use without control. C. Ensure accurate monitoring of food temperatures. D. Lower kitchen safety. Answer C. Accurate calibration of thermometers is crucial for ensuring food is cooked and stored at safe temperatures to prevent pathogen growth. Verification of the ice point on a thermometer should yield a reading of A. 32 degrees Fahrenheit. B. 40 degrees Fahrenheit. C. 0 degrees Fahrenheit. D. 100 degrees Fahrenheit. Answer A. Using the ice point method, a properly calibrated thermometer should read 32 degrees Fahrenheit in an ice-water mixture. Safe storage of TCS foods requires maintaining them at A. 41 degrees Fahrenheit or below, or 135 degrees Fahrenheit or above. B. Room temperature. C. Above 70 degrees Fahrenheit. D. Below 0 degrees Fahrenheit. Answer A. To inhibit pathogen growth, TCS foods must be stored either at 41 degrees Fahrenheit or lower or at 135 degrees Fahrenheit or higher. The FIFO method in food storage stands for A. First in, first out. B. Fast in, fast out. C. Food in, food out. D. Final in, final out. Answer A. FIFO, first in, first out, ensures that older inventory is used before newer stock, reducing the risk of expired food. Unsafe storage practices are evident when A. Chemicals are stored with food and items are placed directly on the floor. B. All items are properly labeled. C. Storage areas are kept clean and dry. D. Appropriate shelving and separation are used. Answer A. Storing food with chemicals and directly on the floor increases the risk of contamination. Minimizing the quantity of food removed from refrigeration during prep helps to A. Enhance flavor. B. Prevent time temperature abuse. C. Improve visual appeal. D. Optimize plating. Answer B. Removing only the necessary amount from the cooler limits the time food spends at unsafe temperatures. Thawing food by submerging in running water should be performed at temperatures not exceeding A. 41 degrees Fahrenheit. B. 70 degrees Fahrenheit or lower, for short periods. C. 100 degrees Fahrenheit. D. Room temperature. Answer B. Thawing using running water must be done at 70 degrees Fahrenheit or lower and should be brief to avoid food entering the temperature danger zone. Cooking whole or ground poultry requires achieving an internal temperature of A. 165 degrees Fahrenheit for 15 seconds. B. 155 degrees Fahrenheit for 15 seconds. C. 145 degrees Fahrenheit for 15 seconds. D. 135 degrees Fahrenheit for 15 seconds. Answer A. To eliminate pathogens, poultry must reach a minimum internal temperature of 165 degrees Fahrenheit for at least 15 seconds. Reheating prepared food for immediate service must result in A. An internal temperature of 165 degrees Fahrenheit for 15 seconds. B. A temperature of 135 degrees Fahrenheit. C. A temperature of 145 degrees Fahrenheit. D. A temperature of 155 degrees Fahrenheit. Answer A. Foods that have been cooked, cooled, and then reheated must reach 165 degrees Fahrenheit for 15 seconds to ensure safety. Cooling food must reduce its temperature from 135 degrees Fahrenheit to 70 degrees Fahrenheit within A. Less than 2 hours. B. 4 hours. C. 1 hour. D. 6 hours. Answer A. Rapid cooling, dropping from 135 degrees Fahrenheit to 70 degrees Fahrenheit in under 2 hours, is required to limit the time food spends in the temperature danger zone. During service, hot foods must be held at a minimum temperature of A. 135 degrees Fahrenheit. B. 41 degrees Fahrenheit. C. 70 degrees Fahrenheit. D. 55 degrees Fahrenheit. Answer A. To maintain food safety, hot foods must be held at or above 135 degrees Fahrenheit. Installation of physical barriers in self-service areas is implemented to A. Enhance flavor. B. Protect food from external contaminants. C. Speed up service. D. Reduce portion sizes. Answer B. Sneeze guards and similar barriers prevent contaminants like saliva or airborne particles from reaching the food. An effective food safety management system integrates active managerial control along with A. Strong personal hygiene, comprehensive training, approved supplier selection, rigorous cleaning and sanitation, proper facility design, and pest control programs. B. Ignoring sanitization. C. Reduced staff training. D. Minimal regulatory oversight. Answer A. A comprehensive food safety management system combines active managerial control with multiple supportive programs to minimize risk throughout the food flow.